Hi, my name is Kevin Goldstein, and we're going to be talking about auto QA. Today, specifically using generative AI to do QA, and even more specifically, leakage-free generative AI to do QA. Now, what is it exactly we're going to be doing? We're going to be using generative AI to look at our code and evaluate things on qualitative aspects, right? Things like conceptual focus, operational cohesion, testability, side effect simplicity. These are things that are very difficult for us to come up with from a quantitative perspective, things like SonarQube and other static code analysis tools. Instead, these are qualitative aspects, and that's why Gen AI is so useful for this. One of the things that we're going to be doing is looking at leakage free. So, what is leakage? Well, I will say first and foremost, leakage is the industry's largest fear of using any kind of external AI tool, such as ChatGPT or Claude or things of the sort. And there's a whole bunch of reasons for this, and most of them have to do with the fact that your code or your or signals about your code are no longer your own. And there's a whole bunch of reasons that it can no longer be your own. Like first and foremost, like plain text exposure. So just flat out, I'm sending some code snippets to ChatGPT. They need to analyze those code snippets, and those go into log files, and therefore that code is now theirs. They have access to it, right? You've got data sovereignty. If you're in the European Union and you're sending code analysis to another corporation that happens to be sitting in the US, you've now crossed some political lines. You also have retention uncertainty. Many of these companies are in the process of legal battles, right? OpenAI is being sued by New York Times. Claude has a couple of lawsuits as well, which means that they are under injunction. They are legally required to store every single prompt that comes their way. And it doesn't matter if they want to use your logs or not, they're there. And then there's also indirect leakage. Let's assume that people aren't going to be using your code and you don't have retention uncertainty and everything else, but you are sending log files, you are sending telemetry, you are sending API keys, you are sending secrets, things that your corporation uses to maintain access to dev environments, production environments, things of the sort. So this leakage is a problem. And then lastly, there's auditability gap. Once you give your code, your processes, your anything to a different corporation, you don't know what auditability you have, right? You can't see who's used the code fragments, what process it used the fragments, if it was backed up. Like that auditability just goes away, and that's what's called chain of custody. Once you've lost your chain of custody, you lose auditability, which is an important thing for enterprises, right? So leakage, it's not just about the technical exposure. It includes jurisdictional concerns as well. It boils down to your irreversible loss of custody. I've given that code to somebody else. I've lost control over it. I can't get it back. Right? There's how do I lose control over it? Both them having access to it themselves, but also the fact that it's leaving our network. Once it exits our network, we can't recall it, we can't audit it, and we have no control over it. And it doesn't matter about the no training assurances that companies provide you, because there's backups, legal holds, and this all makes the ephemerality of the code difficult to manage. Now, whether or not this is true or not is not part of this topic. This is the largest fear that I've come across when speaking to multiple different clients. And what we're going to talk about today is how to manage that. And we're going to manage that with local QA. It's a zero leakage generative AI approach. You're going to get the best of both worlds. It's going to stay on-prem. It's going to be on your network. You can decide how things flow, and you're going to get that qualitative analysis that generative AI gives you. Now, what is it exactly that we're going to be trying to get today? These are some of the things that I already talked about before. I've thrown in the fact that we want to make sure logging levels are in the right place. We want to make sure intent is there, cohesion is there. We don't have any side effects there. But you can start adding more interesting things. Did you name the method correctly? Did you name the variable correctly? Those are interesting things, and those are things that generative AI is good at and useful in QA. What we're not doing today is trying to enforce formal rules. We're not doing quantitative analysis. We're not looking for code coverage, percent duplication, or complexity. Those are all things that static code analyzers like SonarQube and other and their competitors are really good at, and we're not comparing that, right? One of the big problems, though, that people will ask when you're trying to build a solution like this is they say, we've got a pretty complete pipeline that's built up. Somebody's doing their development in their IDE, and then they store it into their source code control. Right here, we're showing GitHub. And then that's sent to a whole package of stuff, right? Like it's going to integrate with Jira, it's integrated with SonarQube, you've got GitHub Actions or Jenkins, you've got all of this stuff. And enterprises can't throw all of this away in order to start using generative AI. And the good news is you don't have to, right? We're doing basically the same thing, and we can piggyback off of the tools that are already there. Great. So very specifically, the code that we're going to be looking at today is this green piece right here in the middle, right? What it's going to be doing, we're going to be booting up an Ollama instance of Docker, and we're going to be loading up ChatGPT OSS that comes in two flavors right now, 120 billion parameters or 20 billion parameters, and we're going to be picking the 20 billion parameters simply because it's smaller. But this is all going to be running from, I'm going to show you how to build it. This is just running from inside of Docker. This piece here is really what we're interested in, right? This is going to be reading from the source code that we're going to be evaluating. It's going to be determining the method that you're going to be inspecting, and then it's going to be generating and sending the prompts to that auto QA that we've built out, and then it's going to be storing them all in a report. We're going to talk about the basics of this, and we're also going to talk about some of the complexities that we run into when we're doing this, right? First and foremost, let's talk about some of the prompt that we're going to be using, right? We want to evaluate individual methods, and we're going to be looking for each one of these separate things. And the way that we're looking for them is that we've added weights to them. Every method starts out with a quantitative value of 100. And as you find methods that violate intent focus, right, we penalize it. We take away up to 20 points. Or if there's conceptual focus, we penalize that. We take away up to 20 points for shallow logic or mixing unrelated concerns, right? There's structural noise that we take away up to 10 points if we see that there's, boilerplate code, inline formatting, unnecessary branching. Testability is a big one. We take away up to 20 points if it's non-mockable, if you're not able to cover it. Extractability, being able to run this as its own process or its own service, right? Naming conventions is one of the things that we threw out there as a possibility as well, making sure that the names are not misleading or reliable to what they want, right? We're going to talk about how we build in this rubric, and we're also going to talk about how we submit each of these processes to the local QA that's up and running. Here you can look at some code. I've posted it all under GitHub, our DevAltis GitHub repository. All right, so let's look at some code. What we do is we basically, in this main string, right, we validate some arguments, we figure out where our endpoints are, we load this the Java path, the Java file we're going to be looking at, and then we query the AI. And this is not that big of a project or process, right? It basically determines where you're writing the report, and then it sends a query executor to the AI. You've determined the method, and you send it some parameters. That's really not what people are going to be interested in. I think what most people are going to be interested in is using this query executor. And that's where that rubric is coming from, right? That's where we say, hey, these are the qualitative things that I want you looking at on a per basis, and you give it the total deductions that you want to be able to look at. And you say deduct 5 points if you're mixing and matching unrelated domain concerns. You want to give it some operational cohesion, whether or not it's got domain, if you're mixing domains, I/O, computation, orchestration, side effect simplicity, making sure you don't have that much of it, things of the sort. Once you've got this prompt built out, this sends it to a report writer. You execute the query, and you add the results of that query to a report, and then the report writes it to file. So nothing too crazy here. All right, let's build this and have a look at what we're talking about. So what I'm going to do at this point is I'm going to bring up that generative AI local instance of it, and we're using Docker. Oh, let me show you that Docker file, sorry. And we're using Docker, and you can see this is not groundbreaking. This is not incredibly hard. We're just harnessing tools that already exist in order to give us what we want within the enterprise. We're going to bring up the Ollama latest, and we're going to wait until it's ready to be processed, right? So we have a entry point in the health check. So we're just going to say Docker compose up build Okay, this thing is coming up. And now we've got a couple of different projects that we can use. Let's have a look at what these are. We're going to run this process finder. And this process finder is going to be looking at this particular piece of code. I pulled this code from a different project. I left it as is. It's really not that big of a file, which is one of the reasons that I picked it. But you'll notice that it does have a couple of different methods that we're going to be looking at today. Very specifically, the find process, assert exactly once, verify platform, things of the sort. All right, so now that we know what we're looking at, let's run this puppy. And we're gonna, you see the thing starting, you see the process starting to come out. Here's the prompt that we're sending it, right? And here's the fact that it's running. So we see the all of the parameters that's being passed into it. So this takes a while to run. So if we skip ahead to look at some of what the output looks like, we can see some of examples that are running right here, right? Let's open this up. And here's what this looks like, right? We see those methods that I was bringing to your attention. Assert exactly one process and shows that it adheres to the main idea, single responsibility principle of 75. Another one is at 60. And so let's look at this. I'm making the statement that anything that's 75% or below is a point where we actually need to be able to look at this code and start doing some refactoring, maybe with the help of AI or not. But let's start looking at what the problems with it are. And I have this broken down in our presentation, and it shows this is the process that we were looking at, right? We can find this process here in the process finder, right? And it's right here. I copied and pasted this code method into our PowerPoint so that we can show what the problem is, right? This doesn't look too bad to me, right? It's a public method. It takes a string of the process you're looking for. It pulls out, finding process. It checks if it's empty or if it's greater than 1. Otherwise, you're good to go. But the AI is telling me that I've only got 75% of this. Well, let's look at this a little bit better. Finding the process and throwing an exception and doing an iteration on them, that is an operational cohesion problem. I'm actually doing multiple different things. I'm not doing cohesive things. I'm not trying to iterate through them. I'm not throwing an exception. I'm not finding a process. I'm actually doing 3 things at once. That's not good. This also means that I've hard-coded some values here, right? Which makes testability a little bit harder. I've hard-coded the fact that I need to pull things out. I need to read logs in order to test this system to see if something has been found, because I'm not giving a returnable value. I need to look at log lines in order to figure out if this is actually working. On top of that, we're mixing assertions being thrown here with logging, right? That's finding, validating, and reporting all at the same time. These 3 things are really what drop it down. So if I look at cleaning this up, right, I would basically have this assert exactly once process that is doing your orchestration. I would have validate exactly once process that is, responsible for throwing exceptions in the event that something is not what I'm expecting it to. And I would log exactly one process. And you can see that if I rerun the system running this new clean methodology, right, we'll see that it says assert exactly one process, which is this dude up here, has a 90% cohesion rate, right? Again, we are now showing the fact that the conceptual focus, operational cohesion, side effects, simplicity, and extractability, they're all working. We're pretty happy with this. 90% is far above the 75% value that I said I need to look at stuff. And so Bob's your uncle. I'm done. Correct? Well, not really. The reason you're not done is I ran this again and I got 93. And what does that mean? I mean, am I really worried about the fact that 9093 is coming out differently? And the answer is yes, because now I'm doing multiple runs and I'm getting the different outputs. How do I know I'm not going to run it one time with 90 and another time with 60? And what that means is welcome to generative AI. You're using a non-deterministic method to ask for deterministic results. There's a lot of ways to address this. A lot of work has been put onto this, but one of the things that most people fall back to is statistics. You run this on multiple different times, you start figuring out your mean and your standard deviations, right? And a lot of people like the statistics approach because it keeps your system simple, clean, and easy to diagnose, right? So you'll notice that, for example, I'll use this assert exactly once process. It's got 3 runs, right? And it's got 86% with a standard deviation of 13. 86% is something that is relatively okay. That standard deviation is pretty high, though. That would actually put me beneath that 75% if I took it all the way to the extreme. However, if you look at the 3 runs that I found previously with the validate exactly once process, verified platform, and log processes found, you'll see that there's 0. That's really what you're looking for. Okay, I really hope that sums it up. I hope you guys have enjoyed this presentation on using leakage-free qualitative AI, and happy coding, everybody.